Okay, so yesterday we looked at how to plot a linear relationship, right? We looked at the numbers. They always go in an ordered pair. We just plotted the ordered pairs, always going right or left first, up or down second, yeah? And today what we're going to do is we're going to look at some graphs of those and then be able to read information from the graph that we're given. So we're going to be going backwards a lot in these particular things that we're going to work on. So let's go to the lesson so I can show you what I'm talking about. Okay? So in the previous lesson, again, we learned how to take the information from the table and put it on a graph. Okay? Now we're going to learn how to represent a linear pattern from a graph. So we're going backwards, right? Appreciate the dog. He's a great artist. So here's a linear pattern, right? Here's another linear pattern. Remember that linear patterns can be given to you as numbers, as pictures, right? Remember, when they're given to you as pictures, be careful. These sticks don't touch. That means you're not counting the image. You're counting the lines that make up the image. If they touched, then it would be 1, 2, 3, right? But since they don't touch, what you're counting is the number of items that make up that. So 1, 2, 3, 4, 5 for the first one. Remember that? Okay, be careful about when you're doing the images. Okay. So you can have linear patterns demonstrated in lots of different ways. Okay. So what we want to do is we want to be able to look at these and find the relationships. Okay? So when you're looking at those patterns, we just had a string of numbers before. And a lot of times it's difficult to see what a string of numbers means. What does it mean when we have just a bunch of numbers together? So we want to look at the graphs or the images to tell us about how things are linked together. So that's what we're going to look at today and focus on today. So here we go. So before we had numbers, we had made tables. So if we had the pattern 5, 9, 13, 17, 5 is the first number, so that's 1, 5. 9 is the second one, so that's the second one is 9, right? And third one was 13, fourth one 17, etc. Remember that? And that's how you get an ordered pair out of them. Then we were able to plot those and demonstrate the relationship.
Do you want us to write this down?
No, I want you to get me a kitten that looks like that. Look at that. Okay. So remember that when you plot the relationship, you're going to have the position in the pattern. If you're using N and T, the position of the pattern, which number, 1, 2, 3, 4, 5, always goes along the x-axis, or the n-axis in this case. And then the value of the term always goes on the y-axis, which we call t in this case, because you're on your chart where they were using N and T. Remember, use the letters that they give you, right? Okay. So let's try graphing a pattern. Here's our pattern. We have 5 sticks making up this image, right? And the second one has 1, 2, 3, 4 more. So that makes it what?
2 + 5.
Yeah, so we've got 5 here. Then we have 9. Then we have what? 13. And then?
T + 4 and +1.
Okay? Yeah. So what's happening is each time we're adding 4, right? So that's our common difference. So that goes in front of our n. Okay? But if you put 1 there, that gives you 4. So I need to have 1 more added to it to get this first image. Remember that? You just test it with where n equals 1. If n equals 1, you should get a 5, right? So if you put t equals 4 times 1, you get t equals 4. What do I have to do to a 4 to turn it into a 5? Plus 1, so that means my pattern needs a 1 added to it. Remember, we looked at those. Practice them if you don't quite remember what's going on. You need to be able to get these linear patterns. All right? Okay? So from that, we can just count those and build our chart. The term number, 1, 2, 3, 4. The term value. Okay? So now, all they're going to do is plot those. So if you're plotting 1, 4, that means go to the right 1 and what? Up. I'm sorry, 1, 5 is the number. 1, 5. I said it wrong. 2, 9 means go what?
Right.
To the right 2, then what?
Up to 9.
Up 9. 3, 13 means what?
Go to the right.
To the right 3 and what?
Up.
Up 13. Make sure you put numbers. And 4, 17 means go where?
To the right.
To the right 4 and then what? Up 17. And if you plotted all of those, like they're going to do on the next slide, you're going to see that they all make a what? They all like in a straight line. Exactly. Okay? Good job. So all they did was plot all of those. And that defines a linear relationship. Okay? And again, linear because they all line up in a straight line and they have a specific relationship to each other.
Are we supposed to write any of this down?
No, this is pretty much a review from last time. Okay? So, graph the following pattern on the axes below. So we see our pattern, 4, 3, 2, 0, 1. So let's just do this one together. So the first term in this pattern is what, guys? 4. What's the second one?
3.
Third? 4th?
1.
5th?
0.
Okay. What would happen if I continued this pattern? What's happening? The numbers are... Yeah, they're decreasing, and after 0, I'd have to get into the negative numbers, right? But if you'll notice, none of our graphs use negative numbers yet, right? So you're not going to have to worry about that in these particular patterns. Okay? Good job. So once you have those, you can then graph them. So looking back at your pattern, okay? Let's just write those numbers down. 4, 3, 2, 1.
Can you tell us in your practice?
Yes, we're just working examples. We haven't done anything new yet. It's 4, 3, 2, 1, 0, right? So that's the first one, second one, third one, fourth one, and fifth one. I'm just bringing the chart down here so that we can use it on our graph. So the first plot would be the plot 1, 4. What does that tell me to go? To the right 1 and up 4. So right there. How about the second one?
To the right.
Right 2 and up 3. Next one?
To the right 3. Up 2.
Excellent. Next one?
To the right 4. Up 1.
Good. And finally,
0.
to the right 5 and stay there, right? Because you don't go up any. What do you notice about the dots? They make a straight line. Yeah, and this line is going down, right? So these are decreasing. But I knew that it was going to be decreasing because what was happening to my terms? They were decreasing, right? So if you look at your original pattern, you'll always have an idea of which direction your numbers are going to be going. Mm-hmm.
Can you put a line through that one?
Now, could I put a line through this one?
Yes, but it says
You really probably shouldn't because all of these are just numbers, right? Does it say does our pattern say we can use fractions? You could, and they would be perfectly fine. Since they're numbers, it's really up to you, right? Now, what if they were cats? No, right? But if it's just plain numbers, you can, right? Unless they tell you specifically not to, right? Which you might see. But in this case, if we it's best not to because all they're doing is plotting the relationship right now. Okay?
This makes me
All right. But you definitely could. All right. Graph the following pattern. So this time they're just giving it to you as a visual. So what's the first, how many dots in the first one?
3.
So 3, then what?
4. Wait, what?
Oh, 5, then what?
7.
7, then what?
9.
9. So there's our pattern, right? So we would just plot those points. And this is your homework, so you're all going to do that one. So I just wanted to show you that you can be given a list of numbers, but you could also be given things from the pictures. So a lot of times you can make a table, but you don't have to make a table, right? If you know the first number is 5, then you can go straight to the graph and plot 1, 5, right? So you don't have to make a table every time. So let's just try this without making a table. So the first shape is right there. And how many sticks make up this shape? 6. So that's the ordered pair 1, 6, right? So you don't have to make the table as long as you know the value and it's the first value. What's the second value going to be? 11. There you go. Right? Just count the sticks that they added to the original shape. Okay? Now we have a pattern. We don't even have to think about counting the numbers. We're adding what? 5 each time, right? Okay? So that's 3. And so the fourth one would be what? There you go. So once you've established a pattern, you don't want to continue counting because it takes forever. Okay? So you don't need a chart. You can just write down ordered pairs and be able to graph using that information. Yeah? Does that make sense? So you don't always have to make the chart. But if they ask you for a chart, they want it. And so you see, we did first term 6 lines, second term 11, so we got exactly what they did. Okay? And then they just, of course, graphed it. If the first term is 6, that's to the right one, up 6, etc. Okay? And there's the completed graph. And again, they're just plotting these pictures, so you can't have a fraction of a picture, right? So for the pictures, definitely just use dots, right? Okay? All right. And so that shows the relationship between those figures. We can use relationships, like we did in the past, to determine future values just by looking at the pattern, right? So if you look at this pattern, the first one is what? 3 sticks, right? Second one is what? 5. Third one is 7. The next one is 9, right? So what's happening? We're adding 2 each time. So we can graph that sequence, and it would help us determine the next term or the next terms in the sequence by simply making sure that the next dots you do all line up in a what? In a straight line. Okay? So let's take a look at what that looks like. Okay. So here we go. We have our linear pattern established. Yes? Yeah. They want us to find the 10th number in this pattern. Now, there are a couple ways you could do this. The easiest way to do this is to connect them with a line, right? So, but if you're going to do that, you're going to want to use a ruler to make sure that your line is lining up perfectly, all right? Because if we're going to read information from this chart, from this table, we need it to be absolutely accurate, right? And so if you just draw a line, if you just draw a line with your hand, sometimes it gets a little wonky. So it's hard to. Using a ruler? Yeah, it's difficult to do on here. All right, there you go. Now, any point on that line would fall in these. Now, I've drawn a line from a pattern that was demonstrated with pictures. Am I technically allowed to draw the line? Not really. Because pictures, you're not going to have half a picture, a fourth of a picture, whatever. But I can still describe the relationship by using the line, and that's what I'm doing here. So they want us to find the 10th value, which means go to the right 10. So all I need to do is go up until I hit the line, and it hits the line right there. So if you go across, what number value does that give me? 21. So the 10th value here is 21. Right? So what would the 7th value be? Go over to 7 and go up until I hit the line, and it hits it right there, which is 15.
Well, you could just do the math.
Yes, but they want you to specifically use the graph. Okay? So if they do that, plot the point that they give you. So if you draw a line, any number on that line is one of the values, right? So what's the eighth number? 17. What's the 9th one? 19. It's 19, yeah, they're 2 parts. Okay? All right? So this is one of the most valuable tools you'll use when you're graphing, okay? Because being able to read other values off the graph is one of the most important skills that you're going to have for working with graphs. That's why we use it. Because we don't want to have to do the math for every single number, right? And many times, these represent real-life situations. So, for example, you want to know how much it's going to cost to have a construction crew at your house, and it's linear. Then you can just find out how many hours they work, go to the line, and boom, it tells you. So it's a really important skill, and this is one that we need you to concentrate on. But all you have to do is, if you were finding the whatever number, so the fourth number, for example, that's your x value, or your n in this case, just go up until you find that value. Okay? So it makes it really easy to do them. But if you're going to do it, make sure your line is very accurate. Use a ruler. Otherwise, if you got off a little bit on your line here, right, just by drawing it by hand, it'll throw off your values. So you must be very accurate. Okay? All right. You're going to spend a lot of time reading graphs and picking the right numbers. So make sure that you know how it's going on. So you see here, all they're doing is connecting the dots to finish off this line. Okay? Again, you could plot all those dots, or you can just use a ruler and draw the line. Just be very, very careful. And then from that, you'll be able to read the n value you want and its corresponding term. Okay? We did that one. So 10 triangles would give you 21 lines. Okay? So find the 10th term in the sequence below. Right? So here's our sequence. So the first number is what? Then 13, 12, etc. Right? So we're going to plot those. Now they made a chart. You don't particularly have to. We're just going to plot these. So here we have them all plotted. So what I'm going to do is I'm just going to connect them with a line. Again, using a ruler to make sure you're very accurate. Doesn't like my ruler on there. Okay. And then if I want the 10th value, all I have to do is count up from 10. Here's 10. Count up from 10, and I hit the graph at what number? 5. How easy is that? Okay? So, but again, a critical skill in algebra. Got to know how to be able to do that. Okay? So they continue the line, and there it is, boom, 10, 5. Just exactly what we got. Make sure you're very precise when you're drawing these lines, though. Okay? Now, another important skill that we're going to do is we're going to be able to describe a pattern from a graph. Describing a pattern from a graph is a lot like finding the pattern that we did before. So when you're describing a pattern, there are a couple of pieces that you need to have. You must have where it begins, and you must talk about whether it goes up, but does it always go up? Okay, what else could it do? Go down, right? Goes up or down by a certain number. Okay? Yes. So your notes, you need to always, when you're to describe a pattern, you must have a start, first of all, and second, tell how much it's changing, either going up or what? Down. Okay? And to do that, you could look at the number values. But you could also look at the pieces just straight from a graph, and that's what we haven't done. We've done these descriptions before when we did our patterns. We did them looking at the numbers or looking at pictures. Now we're going to do the same descriptions, but we're going to look at it from using the graph. Okay? So let's look at the example that they have here. Here's our pattern. They give us the numbers. Here it is plotted on the graph. And the first number, remember, that's just the terminology here. The first number is right here, this dot. And what number is the first number? 1. So that means we're going to start at 1. Now that's not this 1 down here. This 1 means the first number. This is our starting point. Make sure you don't get them confused, right? It's not always going to be 1, 1, is it? It could be 1, 5 or 1, 632. It doesn't matter. Okay? So there's your starting point. Now, if you look at that point, the second number, what's the second number? 4, right? The second number, yeah, is 4. Okay? So to get from 1 to 4, think about what you have to do. So we went to get from here to here, and remember, on the graph, you're only allowed to move straight up or down, right? When you're counting. How many units did we have to go up to get to 4?
4.
From 1?
3.
3. So it went up, go up 3 units. And you'll notice that if you're on this one, to get to this one, how many do you have to go up? 3. To get to that one, how many do you have to go up? 3. To get to that one, how many do you have to go up? 3. So every single dot is exactly 3 units up, right? So you start at 1 and you're going up 3 units. Okay? So we'll look at some more of those just to make sure that we're comfortable with that idea. Okay? So they're just describing that one. Let's go. So there's the first dot at 1, the second one's at 4, and you just like with the numbers, you could use subtraction if you want to. Okay? So you see, every time you go over 1 to the next number, you go up how many? By 3. Go over 1, up 3. Go over 1, up 3. Go over 1 to the next number, you're going up 3. Right? So it's just like walking upstairs. Okay, so here we go. We're going to describe this pattern. First of all, when I'm describing a pattern, the first thing I need to know is where it does what? Starts. And this one doesn't start here. Actually, yes, let's start it at the first number. So starts at what number? Yeah, let's just do the first number. So I don't know. Let's see. Let's find out what they want. This one actually, because it has a line, it actually starts where? At 0, 0 what? 5.5. So we'll look at it and see. This is a little ambiguous. I don't know if they want that or not. So this one could either be described, the first number is actually starting at what though? 5. So the first number is 5. So I'm not sure if they want that 0 part on there. We'll look at it and see what they expect. Now, for the second number, we're not going up. What's happening? Yeah, so if you go across to the second number, you're going down 1/2, right? So let's just put dots on the critical points, which are the ones where at the intersections. Okay? So if we go over to the third number, that's what? 4. But you see, the fourth number, you're just going down 1/2. So you can go down different amounts. So every time you go over one number, you're going down 1/2. Okay? So starting at 5.5, go down what? 1/2. Now, that can be described in different ways. Because if I wasn't allowed to use the fractions, then I could just use these critical points. Again, remember we've talked about the where they cross on the lines. So that means go over 2 and then down 1. So every other number, you would go down a whole. So let's see how they describe this one. Okay. So where it starts and where you're going. Well, clearly we're going down. Okay. Now, yeah, and they're using just the whole numbers. So if you start at 1, now, we don't agree with that, do we? Because where does this graph actually start? At 0, 5.5. But let's just go with what they have. So 1, what net value does that give me? 5, right? So they're going to say it starts at 5. I disagree. Do you disagree?
Yes.
You see why? Because there's actually a line there, okay? And then as you go to the next number, to 3, that's only down 1/2, right? But look at this one. If you go across 2, that means you went down a whole unit, right? But for each unit, it goes down 1/2. Okay? So I'm going to disagree with what they say there. If I was describing that, I would say that it starts at 5.5, 0. But do you see where they're coming from? You can't say that the first number is 5.5. That would be the 0 number. And that's why it doesn't really make sense to say it starts at 5.5 when you're describing it in this way. But really, it starts with 0 and 5.5, right? Technically. But they're using they want the start to be the first number. Okay? So when they say start, even though it really starts here, when they say start, use the first number as your starting point. All right? Don't like it. But we want to make sure that we agree with them so that we get the answer right. Yeah?
What about on the assessment?
Yeah, use the first number. Yeah.
So
if you're doing the start, the first number is what you'll use. No, because that's where I'm getting it. It's from Education Perfect. So this number right here, that's what they wanted as your starting point. Not 0, but 1. Yeah, I agree with you totally. I don't like it. I don't like it either. They should have, if they're going to do that, then they should not have put a line. They should have just done it as dots.
Well, we're going to do the Education Perfect here, so we should do it the other way.
Yes, exactly. That's what I'm saying. So make sure that your starting point, when you're describing these patterns from a graph, always make sure that your starting point is which number?
1.
The first number, right. So
we're
we're, yes.
So you're not laptops.
Yes. Okay? All right. All right. So nothing really super new there. The only thing that we did that was actually new is describing the pattern from the graph, whether it's have a start and then whether it goes up or down and by how much. And that's just a matter of counting. And so if you can count, you can do that.
Yeah.
All right? Okay. So I'm going to give you an assignment. And let's see.